This is a short video to show you how to properly calibrate a boom sprayer. In turf care, boom sprayers fitted with flat fan nozzles are used for broadcast applications to large areas. To get started, refer to the product label for instructions. For example, the amount to apply to a given area, coverage directions such as the amount of product to use for a specified volume per acre, as well as sprayer configurations and/or droplet size requirements. The basic steps are: using the label, determine the amount to apply per unit area, both the active ingredient application rate and the amount of finished spray mix you will apply. Always start with a clean sprayer, set up exactly as it will be used. In the process, be sure the nozzles on the sprayer will allow you to deliver the target volume using reasonable operating conditions, meaning mid-range pressures and a safe travel speed. Also, be sure your boom height is correct based on nozzle spacing and fan angle. Check the sprayer's pattern. Be sure all the nozzles match and are in good condition. Next, mark off a representative test area. You then treat the test area with water using your standard operating procedures. Next, determine how much water you use to treat the test area. Compare this volume to the label directed amount and figure out if you're on target. Finally, make adjustments if necessary. Here's what you'll need to get started: the product label, a measuring wheel, area markers, for example, turf, paint, or flags, unless of course you already have a known area to work in or a test course set up. Of course you'll need water, the sprayer you need to calibrate, some form of timing device such as a wristwatch, stopwatch, or even a cell phone, and one or several accurate liquid measurement containers. Also, it may be convenient to have a calculator handy and unit conversion charts. These charts may come in handy if you need to convert fluid measurement units, for example, ounces to pints, quarts, or gallons. You can find conversion charts in Section 1 of the Virginia Cooperative Extension Pest Management Guides. Now, there are several ways you can approach this job. In all cases, you will save time if you start with a set of nozzles that will allow you to deliver the correct volume. While you're at it, check the product label to see if it requires a specific kind of nozzle or has droplet size requirements, and make sure the nozzles you're using will allow you to make the application according to label directions. You can use this formula to calculate the flow rate of one nozzle and to figure out what nozzle orifice size and operating conditions you need to use. In this equation, GPM is the nozzle flow rate in gallons per minute. GPA is gallons per acre. MPH is travel speed in miles per hour. And W is your nozzle speed spacing in inches. Finally, 5,940 is a constant used to resolve all the different units in the equation. However, nozzle manufacturers have done much of this math for you in their specification charts, so you can use them to identify operating conditions that will allow you to make the application using the nozzles you have, or if what you have won't work, you can use the charts to figure out what nozzles you need. Then, treat a known area to confirm that you're on target. A test area of 5,000 square feet is about the minimum size to use to calibrate equipment for a wide area broadcast treatment. If you have access to an adequate sized test area of known dimensions, definitely use that. For example, the playing area of a football field is 160 feet by 300 feet, which equals 48,000 square feet, which is about 1.1 acres. If you treat it side to side from the end zone to the 45-yard line, you will treat about half an acre. There are several ways to determine the amount of water you apply to the test area. If you are certain your tank volume marks are accurate, fill the sprayer half full with water, apply water to the test area, and, after finishing, see how much water is left in the tank. Subtract that volume from the amount you started with to calculate the amount applied. You could also time how long it took to spray the course, then, using the same operating pressure, collect and measure the amount of water released by the system in that amount of time. Now, let's assume a product is supposed to be applied at a rate of 1.5 ounces per acre in 20 to 200 gallons of finished spray. And to balance coverage versus time considerations, you opt to apply that amount of active ingredient in 40 gallons of finished spray. Knowing that there are 43,560 square feet in an acre and your target is to apply 40 gallons per acre finished spray mix, you should use about 4.6 gallons to treat 5,000 square feet, or 20 gallons to treat half an acre. An easy way to confirm your application rate is to use the so-called ounce method. Mark off a linear test course based on your nozzle spacing. Charts giving distances can be found in the Virginia Corps Manual and the Turf Pest Control Manual. You can also get ounce calibration cards from your local Virginia Cooperative Extension agent. Operate your sprayer under field conditions as you drive the appropriate distance. Fill your sprayer tank half full with water to approximate an average weight and get a running start. Drive the measured distance several times while operating equipment and record the travel times in seconds. Then, in a stationary position, operate the sprayer for the average time it took to drive the course using the same engine speed and pressure settings. Catch the output from one nozzle during that time in a container marked in fluid ounces. Output in fluid ounces equals gallons per acre applied. This method works because the test area is 1/128th of an acre and a fluid ounce is 1/128th of a gallon, the same proportions. Note that because your nozzle spacings probably won't change, an ounce calibration test course can be set up in a convenient place and used often to recheck your boom sprayer's output. However you decide to check, if your sprayer is applying the correct gallons per acre, you're good to go. If not, make adjustments and try again. Now, because you need to increase the pressure fourfold to double your flow rate, pressure is best used to make only minor changes in output. If you double your speed, your application rate will be reduced by half. At first glance, changing speed seems like a good way to make large changes. However, there are limits. People often don't want to travel slowly due to time constraints. However, high operating speeds can be unsafe and may result in poor coverage. In addition, if you compensate for increased speed by increasing pressure, your equipment will release more small, drift-prone droplets. For these reasons, adjusting speed is only recommended for making moderate changes. If you need to make a large change in application rate, the best thing to do is change your flow rate by changing nozzles to ones with a different and appropriate orifice size. If you decide to change the application volume and change nozzles, you will need to recalibrate the sprayer. And even if you continue to use the same application volume, in our case 20 gallons of finished spray mix per acre, do calibration checks at regular intervals throughout the season to confirm your delivery rate. The reasons for regular calibration are that equipment settings can slip out of adjustment. Normal wear will increase a nozzle's orifice size, which in turn will increase its flow rate. Nozzles can also become damaged or plugged. Nozzle screens can gradually accumulate debris as well. When this happens, you may not see an obvious change in spray pattern, but output will be reduced. In these instances, the best fix is to replace damaged nozzles, unclog or replace plugged ones, and clean or replace screens. Still, do a quick calibration check after you change or adjust any sprayer components or settings. If a pesticide is to be applied at a certain rate per unit area, using properly calibrated equipment is absolutely essential.